Rumbidzai Matemba will present her PhD research topics. For some of you that don't know her, she is part of BSU. She's working based on Zimbabwe. And since 1 year ago, she started her PhD in the Wageningen University with Fred Van Ewyck, with the advice of me and other people that is in the slide in the screen. Rumbi has been working with us for 7 years, yes, 7 years in Zimbabwe, and is very helpful for the scientists in Africa. Rumbi, please.
Thank you very much, Dr. Wan. Good morning to you all, and welcome to this seminar. So, the introduction has been given already by Dr. Wan. My name is, in short, is Rumbi, and I am happy to present this seminar on behalf of the Biometrics and Statistics Unit. As I start out on this journey of learning, I hope to engage you all in the process, knowing that you possess a wealth of information, and I will be able to gain from the feedback which you are going to share with me. So that's one of the key things which I'm really looking forward to after this presentation. So that's the thesis title. We are trying to improve G by E analysis using Pedigree and weather information. And mixed models and Bayesian methods are methodologies we are going to try to apply to this data and see how we can improve these analyses. So data collection, as we all know, is a very costly activity when we are looking at all the projects that are collecting data, and project leaders are doing their best to make sure that they reduce costs or they try to make the most out of this data. And one of the things that we can do is to develop efficient analysis which can contribute to that. So that is why I set out to do this task for the breeding program in Africa with the assistance of the Biometrics and Statistics Unit. So this is the overview. I will present to you the objectives. I will talk about the background of multiple environment trials, some challenges which are related to such a meta-analysis of these METs, the methodology for my thesis work, some statistical methods for G by E analysis which we will employ, which will help us to determine when and how to incorporate additional information like pedigree and weather data. I will show some preliminary results as well, and I hope to receive your feedback at the end. So that's what it is, the thesis research. We are trying to evaluate the efficiency of the East and Southern Africa maize breeding program to propose improvements for the design of trial networks and to enhance cost-efficient data analytics for enhanced selection decisions. So in the end, readers should be able to know a lot of things in detail as they do their selections for their work. Some of the specific items which I will look at are how to identify suitable trial locations, the least number of plots for maize hybrid trials, how to improve the definition of selection environments using advanced G by E. This is a simple background of multiple environment trials. So we are looking at a representative sample of environments from the target region. We are trying to develop new varieties. There is need to routinely test candidate genotypes in these to identify those which are superior and to assess G by E. to be able to understand its trends, patterns, and then help inform the selection decisions. Now, these procedures which we are going to develop are all part of a meta-analysis, and there were some challenges which I encountered as I prepared for this analysis. So I'm simply going to highlight them for all of us, just so that we know some of the things that are related to that. What are the challenges? Having access to the data to be able to begin doing these analyses. Structure of trials, these change as we move from one year to the next, and as we look at different projects in Africa, objectives change. Different genotypes evaluated in different locations within the same year. Some of us are used to, for example, having very balanced design, the same genotypes across locations. It may not be possible. Breeders have certain considerations. They look at what is preferred in a specific location. That becomes the check. You go to the next location, that becomes another check, and so on and so forth. So this brings a lot of unbalance in the data sets. So multi-layers ultimately can be seen in this data, and some analytical methods are suitable, some are not. So we are trying to focus on what works, and then we try to improve or develop on that, build on that. And so this is what I'm trying to do. To evaluate and optimize the testing network periodically will definitely help to overcome some of these challenges. So we want this trial network to suit breeding objectives. We want this trial network to be able to suit product profiles for the material which breeders are developing. And we need specific environments for these with specific characteristics. And the only way we can do that is to really make sure that we understand these G/E trends. Improving analysis procedures is one way which is very helpful. All these are benefits for improving analysis. We will pay close attention to some of these unbalanced structures of the data, these multi-layers which I spoke about earlier on, to make sure that as we do our predictions, our estimations, we really come up with meaningful results. As we generate all of these analyses, it can be really difficult for breeders to work with this script in that, 10 scripts to do A, B. Here, I point out the importance of the use of breeding information systems to facilitate these kinds of analyses. So this will make life easier for breeders. They will be able to cope as they do their work, analyze data, and make sure that results are available. I will present the methodology for the thesis work. This is a summary of the data which I plan to use for this study. So we have regional trials. These regional trials are advanced trials which are set out in East and Southern Africa. So this is the period for which I hope to obtain this data, conduct the analysis, and then propose improvements based on that's 2001 to 2018. So in the beginning, as the breeding program began, only 2 groups of hybrids were evaluated. So here we have the number of years in which evaluations were made, the number of trials which were conducted, in what number of countries, and in what number of locations. So that's for these 2 groups of hybrids. as the breeding program in Africa began, the focus was always on grain yield under different stress conditions. Later on, from 2013 to 2018, and as the breeding program evolved, we had some splits in the material. So now we have early hybrids, early maturing hybrids, intermediate maturing hybrids, and late maturing hybrids. And also this is the data for these groups of hybrids, the number of years in which that has been going on, the number of trials, and here we are still counting because verifications and the data is still in progress. The number of countries at the moment and the number of locations, still the focus is on grain yield under different stress conditions. Now, some of the limitations that are posed by the data. Availability, as I said, incomplete metadata or key traits. So you really can't, you don't know what to do when a plot size, for example, has not been specified, but you would like to have that as a covariate in an analysis. For these incomplete block design trials, we have plot sizes ranging from 2 square meters to 12 square meters. So if you really don't have that key information, then it can be difficult during the analysis stage. When experimental designs are not correctly specified, this poses a challenge. We all know that, I mean, people in the breeding program, we all know that they are incomplete block designs, but then if you find that some specific analysis which incorporates weather information, pedigree information. So it's really difficult when we have in a pedigree name, it has been changed, and within its name you find something like Striger, plot 1. These are just examples. It's difficult to handle that pedigree information. The procedures for its curation are difficult, they take time. So these are some of the challenges. Having row column information, we will simply conform to obsolete methods of analysis when we don't collect such kind of information that will enable spatial analysis. So it's really important that all of these things are considered as these trials are conducted. Now, in this slide, I will show just the numbers of trials for the two groups, the two regions, East Africa and Southern Africa. So for these two groups of hybrids, as I said earlier on, from about 2001 to 2012, these are the number of trials for East Africa, which are available, which have complete information, and which are ready for analysis. From Southern Africa, again, during the same period of time, these are the numbers of trials which are available, which are complete, and which are ready for analysis. This arrow here simply shows the time frame where key donors like Bill and Melinda Gates Foundation began to make huge investments in collecting some of this data. So that was around 2008 onwards. So the current total numbers of trials available for analysis for East Africa, there they are. For Southern Africa, these are the totals. You may remember, earlier on I mentioned that these were split, the two groups of hybrids were split. East Africa, early maturing, intermediate, late, those are the number of trials. Southern Africa, for these groups of hybrids, those are the number of trials. The totals, the current totals of what is available for analysis is down here. I have put in a brief summary at the end. That's the total number of trials, 1,486. When we are looking at all groups of hybrids across all of these 18 years in which these evaluations were done in Africa. East Africa trials are 668. Southern Africa trials, 818. The Southern Africa trials with complete data are 470, and that's the percentage, 58% out of this 818. But when we're looking at the percentage out of the total number of trials submitted, and this is what is in the database from the counts I've made up to date, that's the total percentage, 32%. Now, the data which is available for me to use for this analysis at the current moment is what is coming from Southern Africa, because that's where the complete sets of data are coming from. So we have some pedigree information, some weather information from those ones, and I can proceed with the analysis. I will give a brief outline of the statistical methods. So the major aim is to be able to conduct a genotype by environment analysis in the best way possible. So we are going to define the methods or statistical methods, and then we are going to determine their performance in doing this G by E analysis. We are trying to identify suitable trial locations. We want to know what is the maximum representation of mega environments with the minimum number of locations. So this hence is appropriate selection. If we look at the breeding program in Southern Africa, in Zimbabwe in particular, it's slowly mechanizing with better quality of operations in tillage and harvesting. So sometimes breeders are thinking about, instead of going out to set new trial locations, why not understand G by E trends in the existing locations and then expand the work they are doing within those trial locations they already have, as it is cheaper than going out to set out new trial locations for evaluations. So these are some of the things that we are going to be considering as we develop these methods. Some trial analyses have biased against poor environments. So informative trials, less informative trials, stress trials, how can we be able to do a combined analysis, a meta-analysis of these METs, taking into consideration all of this and not quickly disregarding those trials, for example, with the low heritability, just because they have a low heritability, and yet we know that for some stress trials, heritability will be low. So we consider maybe downweighing less informative trials, looking for a measure of individual trial quality that can be used as a weight in subsequent G by E analysis. So this will help us to have a G by E analysis that has already taken into consideration all of these different things. We are going to look at how to define what is it that I'm calling a weight in a G by E analysis. So we will try to use pedigree and or climate information and define appropriately how to include these and when to include them. This is one of the methodologies, a mixed model type of methodology, whereby in the first stage, we are conducting analysis per trial, looking at individual trials paying close attention to the structure of the trials, doing quality control checks, obtaining adjusted means and the weights for these trials per genotype, focusing on within trial modeling, the incomplete blocks for the Africa trials. In this case, this is not really going to be helpful for us as we don't have the row column information, but it's a very powerful technique which enhances spatial analysis of these field trials. In the second stage, the adjusted means from this first stage are the ones which are carried into the G/E analysis. And the main task is to model G/E in terms of additional information, which I've already discussed. So I will just briefly show you a step-by-step approach to understanding and to identifying the real G/E interaction. These are some of the models which we will use later on for this G/E analysis to observe the clustering of trial locations and to identify those trial locations where most of the signal is coming from. This is part of how I think of partitioning the G/E interaction. So we have a simple model over here which shows how yield is explained. For the environments, there are different components for that environment. For the G/E as well, we have different components. So for the environment, we are looking at the location years, what's happening across years for such a big data set, the combination of location year effects, and then for the G/E part, what's happening with the G by location, genotype by year, genotype by location by year interaction. So this will help to zoom in into these layers which I've been talking about of the data, and then pick out where most of this noise is coming from, and then try out to design our networks from that. So environments can be partitioned into that, and the G/E components into that, to interpret the G/E, what has caused it, and then we define the number of years, the number of locations. Remember, in the first part, that's one of the things we are trying to do, define the number of locations which are suitable for us to proceed with these trials. How to model the G/E analysis, and how to do our predictions. So this is going to be helpful. Understanding the causes of the G/E interactions, G/L, what does that mean? We're looking at the differential genotypic response to conditions that are particular to the location. G/Y, what does that mean? We're looking at zooming in into the year, season effects. G/L/Y, we are zooming into that location of, that combination of location and year or season combinations. Which causes are likely to be repeatable, because once we identify these, then we will be able to structure the target population of environments and do good predictions within them and quantify the predictable component of the G/E analysis. This is work which is very similar to what I plan and what I plan on doing for these data sets from Southern Africa. So we have ways of incorporating additional information. How do you incorporate pedigree information? How do you incorporate weather information? So this is an example. In this case, we have different models, about 7 models. So we have a model which is looking at environment and line, a model with environment and molecular markers, a model with environment line, weather covariables, and so on and so forth. So this will be able to help me to dissect all of these G by E patterns, have a clear picture, a clear understanding of what is going on. And I think this will be very useful for the breeding team. I also will look at Bayesian methods for G by E analysis, which are slightly different from the mixed model approaches, which I've explained in the preceding slides. So with this approach, a breeder can be able to incorporate prior knowledge and inferences that are conditional only on the observed data. So you can think about what has been happening for these trials in the past years, and then you incorporate that information in the recent trials that they are conducting and see if that has helped anything or if that has affected their results. So this is part of the multivariate analysis which I will do. Some preliminary results from the analysis. If we look at the average yield by stress types, so we had about 3 major stress types: optimal, low nitrogen, and drought for these groups of hybrids. So we have optimal in blue, drought in red, and then low nitrogen in green. So for these groups of hybrids, the groups which existed in the very beginning of the breeding program, we can see that for drought and low nitrogen conditions, there really appears to be so much similarities for these two kinds of trials. Is it that the trial locations for drought and the trial locations for low nitrogen are performing equally well, or there is something that we need to understand? So that I will try to dissect and understand when I include pedigree information, when I include weather information. I will try to determine that. So yeah, these are just the average yields by stress types across the years 2001 up to 2012 for these groups of hybrids. For the later groups of hybrids, we have fewer trials, as I said, at the moment. But as more information comes in, I will be able to try to understand these trends. So these are the most current groups of hybrids, and we are still trying to figure out how this information will help us. Now this is a histogram and a density plot superimposed over it of heritability across trials. The measure of heritability is what most breeders are interested in looking at as they advance material, do their selections. In this case, for example, this is for early to intermediate maturing hybrids in that period. Those are the management conditions. And so we see that this is how the heritability estimate is distributed across the years. The same for ill hype trials in the different management conditions with the different colors. That's the distribution across years. These dotted lines simply show the average heritability estimate for example, drought conditions. What was the average heritability estimate for the trials under that condition? The blue one shows for optimal conditions, the yellow one for low nitrogen conditions. This is for the most recent years up to 2015, because this is the data which I already have and which a lot has been done on it so far, and I think analysis can proceed on that one. So for E-hyb, early maturing hybrids from around 2012 to 2015, late maturing hybrids, I haven't got this for intermediate maturing hybrids because of so many trials missing. So maybe later on, I will be able to have some trials to show results for. Now, a summary of everything that I have been saying. The descriptive statistics, the variance components analysis show strong historical G by E patterns. And it is necessary, there is need to dissect this G by E and understand it fully. So there is need to test the sources of G by E interaction, measure the relative sizes of this interaction, select and use the most appropriate statistical models for prediction of genetic values and related analysis. There is need to model this G by E using these methods which I have described, which are the next stage in the analysis, and then find these good models, which will include specific parameters like pedigree and environmental information. Some of the expected outcomes of this meta-analysis of the METs: a cost-effective evaluation network for developing new maize genotypes, enhanced but cost-efficient analytics of breeding data, and we hope to automate them and make sure that they are user-friendly. I would like to thank my supervisors as well as teams which I've been working with, the Biometrics and Statistics Unit, the GIS team for providing the weather information, the data management team for helping with the cleaning and formatting the data for analysis, colleagues and friends. So this is the end of my presentation. I would like to thank you all for coming to participate, and I would like to leave this time for any inputs which you may have. What could be useful for breeders? How do you think I can include some approaches which I may have left out? So yeah, this is what I hope to hear from you. Thank you.
Thank you. Thank you very much for a very interesting presentation. And I was just wondering, in terms of the weather data, what are the variables that you're thinking to include in your analysis?
Okay, thank you for that question. And sorry, I did not include that in the presentation, but I have weather information from around 1979. Although I will be focusing on these years, I have rainfall data. So I have minimum and maximum temperatures, I have solar radiation, I have dew points, I have relative humidity. So yeah, amongst the major ones, temperatures, rainfall, humidity, and solar radiation, those are the ones which I thought for traits, for example, like anthesis to silking interval, and that's mostly important for drought trials. I think these weather covariates are important for those kinds of trials, to know them and to analyze them efficiently.
Yeah, what's the total number of the environmental covariance you include? Because if you include many, right, and then the interaction will be not easy to handle. So
the total number, thank you very much.
How much you can handle?
I have 4 major weather covariables. So that's rainfall, temperature, solar radiation, and relative humidity. So I'm hoping that if I start with a small number, I make some conclusion based on that. If there is need to investigate more, then I can look at more.
Just a comment. Actually, you can include as many as you want, because you can include in the same way that you include the markers, in which you include thousands of markers. You can include. It depends the way you want to include in the model. If you include like a relation symmetry for environment, or you are interested more in specific variables, environmental variables that you know the effect, or you can interpret the effect more easily. But yeah, I guess at the end we will use what makes some sense for readers in order to define the environments and to choose the environment. How those environmental variables in the model can help us to select the environments, the existing environment or new ones. Another question. Okay, hello.
You mentioned weighting down certain say trials. I wanted to ask what criteria must you choose? What criteria do you use to weigh down, as well as what do you determine in the best trial for you to be able to weigh down?
Okay, so thank you, Tatenda, for that question. These trials are set out in various environments: optimal, low nitrogen, drought, and a lot of things happen just because of a management condition in which that trial has been conducted. Some of these things which affect the way genotypes perform in a trial location are caused by the genetic makeup of that genotype which has been evaluated in that trial. Some of the things are just the weather that was prevailing during that period, those material we assessed. So I am trying to define these weights based on that. A weight can be weather information based, a weight can be pedigree information based. You can look at even the soil characteristics of a certain trial as a weight. Plot size can be something that can be considered as a weight. So I'm going to define. I haven't made a specific conclusion at this point, but that's what I'm hoping to define, exactly how to define these weights. Are you answered?
I have two questions. The first question is, why don't you include molecular markers in your model? And the other question is, how do you evaluate the best model, Bayesian model or mixed model? Also, how do you define what is better, or if you have a methodology for this?
Okay, thanks for the question. So the reason why I have not included the molecular marker data, this availability of information, I'm trying to avoid going around in circles, so it's better to work on what's available, for example, at the moment, and then maybe later on, if the information is available, I could incorporate it. At this point, I will not spend too much time on trying to look for it, etc. So I think for the molecular marker data, this is why I won't focus too much on that. And then for your second question, the Bayesian methods, and then the 1 and 2 stage analysis methods. So I'm not really after concluding on which one is the best model as such, but I'm looking to give a recommendation to say, when you have this structure of data and you want to include weather covariates, this model behaves better. So I'm not going to rule out which one not to use, which one to use, but rather to say, if your objectives are like this, try this method. It has really proven to be useful. So that's how I'm going to, that's the approach which I am taking. I don't know if I've answered your question well, but I'm not looking to saying this is the better method as compared to this one, or this is useless. No, I think it's going to depend on the data sets as they come in, their structure, and yeah, that's basically what it's going to be dependent upon.
Okay. Okay, thank you for your presentation, Rumbi. So in your trials, you've talked about 3 categories, like the drought, the low end, and the optimum. Mm-hmm. But I think maybe some breeders put experiments like on farmers' field, mm-hmm. and maybe they experience not the managed type of drought, but mm-hmm. maybe random drought, or in low end field, it's not like they have created that low end field, but they put it on a farmer's field. So then maybe they suffer from random low nitrogen that's not in a managed low end. So how are you going to incorporate those? Like, how are you going to separate the drought from the random drought trials and from the managed drought trials?
Okay, thank you, Edna, for your question. So at this moment, I really don't have information from farmers' fields or those trials which were conducted by the farmer. At this point, I only have trials which were conducted in the CIMMYT locations, research stations. So I hope to develop these methods from there, and then maybe later on we can advance that to those type of trials coming from the farmers' fields themselves. So at this point, I really don't have what's coming from the farmers' fields.
Yes, I have a question exactly on this slide here, because I think it's a fascinating slide that we have 2 different breeding programs in Africa, one in Eastern Africa and one in Southern Africa. The guys in Southern Africa managed to produce 58% of data that are relatively complete and can be used in a meta-analysis. The other program manages to produce, and you were graceful enough not to put it there, but they seem to have produced about 2% that can be included. Can you explain a little bit what is the missing information, what is going on, why is there such a stark difference between these 2 breeding programs? And the second question is a little bit, you mentioned that in 2008 more resources became available, but it really seems that the amount of data produced is relatively similar over the years. So have they gotten more and more inefficient, the breeding programs, or what's going on?
Okay, so to answer your first question on the numbers of the trials, so this is what's available in the Maize Finder, which is the database that's actually storing this information for these types of analysis and any other. So I'm simply trying to extract this information from there. I don't know exactly what is going on, like the missing information, is it with the breeders or is it somewhere else where we don't know where it is? So I don't have a clear answer for your question on that part, but I do know that I do not have it. So sorry, I don't have the full answer to that. And then the second question on the efficiency, I also don't have a full answer.
Maybe something that we need to think, this is only hybrid evaluation, not a breeding program.
Okay. From East Africa. Yeah. Okay.
Yeah. Thank you for a nice presentation and taking up an important question. I think it's not adequately answered to the breeders so far, and I wish you success to answer this question to breeders, making it clear that this should be the strategy going forward, yeah. Which is very challenging, I think.
Okay.
But my first question was, the heritability you presented, does the model include G by E and in it to calculate, or is just for the one environment?
This part?
Yeah.
Sorry. So here I haven't done any modeling. This is just a first step into trying to understand the distribution of heritability estimates for trials across years. So in this case, for example, the management conditions are 3. These were the major ones for these 2 groups of hybrids: early to intermediate maturing, and then intermediate to late. So I'm trying to show the distribution of the heritability estimates across trials. So we have in 2001, how many trials under drought. We calculate the heritability estimates, and then we plot that across years. So this is 2001 to 2012. There isn't really any modeling at this point. This is just trying to bring out the patterns in the data, looking at important breeding statistics and descriptive statistics. So I haven't really...
Okay, yeah, that's what I want to understand.
I haven't included.
How, let's say, broad sense heritability each year may be high if you have replications pretty good managed, but if your year by genotype interactions or year by location interaction get bigger, then the heritability across the with the GYE in the model gets smaller, right? If genotype component gets smaller compared to the interactions, so maybe that's one of things breeder might be interested to see how big. One of things year, whether year effect is very large, then the location themselves, then year is, you can't choose any year. You have to choose, that's the year you have to face with.
Okay. Yes, and
Right.
I think what you are describing is what is part of these slides, whereby we are saying that's G by E, and we dissect into these different components so that we are adding in where the pedigree information at these points to find out exactly where we had the most noise and then adjust accordingly. So I think your question
Yeah,
is
regarding pedigree, what is that pedigree will also be correlated, like the pedigree component of 2, like hybrids grown this year and next year may be correlated environmentally and may be correlated by the pedigree themselves, because the breeder are choosing similar type of inbred lines to develop those hybrids. Right? It's two maybe like stacked together and difficult to separate.
Yeah. Thank you. And I think we'll pay close attention to that.
Yeah.
Yes.
Thanks for the presentation. That was pretty good. If you stay in that particular slide, it seems that you're going to focus in a particular GYE model, in this case, the specific interactions. So this is a very quick question. So is your study or your research project trying to also answer how the genetic correlation between 2 environments is linked to the environmental covariates? And if so, how exactly you're going to do it? Because you know, sometimes you define multiple environments and you end up calculating genetic correlations among all those, and most studies stops there because they don't have environmental data. But in this case, it seems that you're going to have both environmental data and multiple environments. And usually they just stop at saying, okay, you have these 2 environments and this is the genetic correlation, 0.5, 0.8. But usually people don't go further. But since you have environmental data, I was wondering if you're going to do something similar with the environmental indexes or something to see if at the end of the day, this genetic correlation is backed up because the environments are also very similar.
I think, thanks for your question, but I think from my understanding of how you're explaining this, that component will be investigated. So from my understanding, if we have a low correlation, that is an indication of G by E. And you need to go a step further and find out the patterns in this G by E. So yes, the environmental information is going to help me understand if this low correlation was had some contribution coming from whether in covariables or was it pedigree information. So I think to some extent, yes, what you explain has a link to some of the analysis which I would do, although I don't fully understand everything that you've asked.
Just a little bit comment to what is said is choosing an environment component is a very difficult task, and you have to discuss with the breeders. Sometimes they may have better idea. For example, for wheat, the night temperature itself seems a good predictor of what can be happening that year in Oregon, for example. So even if you have some variables, blah, blah, it may not be like meaningful to explain the genetic, the correlation that we're trying to achieve.
I guess the problem is that most of the time we end up understanding, okay, there was G by E, but we are not able to extrapolate to other situations. And I think that's the part of it seems to be interesting with this research project because you seem to have the information from all the years to at least answer more into that topic.
Yeah, it should try to answer that, but we have to be getting good variables to explain what
Yeah, for sure.
Because
Okay.
in your model and here, you didn't show any environmental data. How you incorporate into this model? It's the normal conventional model. Yeah. Genotype location in here. You didn't incorporate the others.
I did not, I'm sorry I didn't show these four weather information which you would like to see. But what I hope is to do is to formulate models which are going to be different at each point. What combination of, okay, the first, let's look at maybe the last model where we are looking at environment, marker effects, weather information, and the G by E. So this is similar to what I'm trying to do to dissect this G by E and understand its structure. So I'm sorry, at this point I did not show the exact weather information, but yeah, I will do that next time. At this point.
That's what we asked.
Okay.
We want to see some meaningful or valuable information from this kind of analysis.
Okay.
Not only the basic GIE
Okay.
interaction.
Okay. All right.
We have time for one more question. If not, thank you for the audience and for very good questions. And thank you, Romy, for your presentation and your answers. Thank you all.